All right. Okay. You guys have 2011 NDC code book. Everything is going to be based on 2011. This chapter 3 walk you step by step about for all the requirements that you need power and lighting for a residence dwelling. So let's go ahead and start going through the most important thing. So the most important thing, guys, that we're going to be doing, this one is determine the number of we have small appliances circuit. Should have done that. I always forget to power myself. Take a second to put my smartphone on so we can highlight things. So we're going to do, guys, the lighting and the power and all the requirement for lighting and power. Oh, come on, Chad. There you go. Okay, so we centralize that one. All right. Receptacle outlets requirement, if you guys want to highlight that one, this is what we're going to be doing, as well as minimum number of lighting and small appliances circuits that we're going to be doing. So 3 things we're going to do. Number 1, how many receptacles and where do we need them in residential? How many lights and where do we need them in residential? And how many branch circuits and where do we need them in a residence? Okay, so that's what we're going to be doing. Before we start with this, guys, before we summarize it, let me just go over a couple of definitions that you know. Branch circuits. I'm going to remind you of the project that we have. Our project is going to be 4 apartments. Each apartment, Zach, is going to have its own panel, sub-panel, and all the apartments are going to be fed from a main panel. And we're also going to have a 5th panel that's called house panel. A house panel is the one that you feed all common places from. Okay, everybody knows how the scope of the project. 4 apartments in one complex. They're going to be fed from 4 panels. So each panel is going to have multiple branch circuits coming out of this panel, right? And we're going to have a main panel that feeds all these 4 panels. And also we're going to have a 5th panel that's going to be the common panel for all they call it house panel, for anything coming between all the 4 apartments. Cool? Branch circuits. Branch circuits defined by the code, guys, the last overconduction device and utilization equipment. So we're going to be talking about a 20 amp as well as 15 amp branch circuits. So if you put all your lights, you grab your lights and you put them, this is your branch circuit. If you put all your receptacles and you put them in one circuit, and that's going to be what they call it, branch circuit. The last overconduction device and utilization equipment. These are LL. Questions about branch circuits? Branch circuits, the last overconduction device, right here, utilization equipment, here and down. So that's my branch circuits. Let's move into feeders. In our project, you're going to have, guys, 5 panels. Each one of them is going to have close to 20 branch circuits. So do your math, 5 times 20, close to 100 branch circuits in this apartment, give or take. Okay, so just give you an idea how we're going to be doing it. The second thing is the feeder. The feeder, guys, defined as basically the conductors between 2 overconduction devices or 2 equipments. So here's an example. In our apartments, if you guys look at the way we're going to be doing it, here's panel 1, panel 2, panel 3, panel 4, and panel 5. And right in here, we're going to have an overconduction device 1, 2, 3, 4, 5 right here. Say each one of them is 100 amp. And right, so the conductors from here to here, these are called the feeders, right? This is my feeder. If you take from this panel, this is panel 1, panel 2, panel 3, panel 4, panel 5. And this is main panel. This is how your project is going to look like. Main panel feeding 5 other panels, 4 for each apartment and 1 for the common place between all of them. So the feeders between the main panel and the sub panels are called feeders, by code, feeders. And the branch circuit, let me just show you a quick branch circuit. You come over here from here at 20 amp, and you go feed all your lights, for example, light, if you decided to use a branch. This will be my branch circuit, and this is a feeder. Any question? Any question about the definition of a feeder and the definition of branch circuit? And how are they related to the project that we're going to be doing? That's exactly what we call riser, one-line diagram, guys. Later on, you guys are going to be drafting this in CAD for me. But I thought throw it there right away for you. It talks about source of separately derived system. I don't want you, I don't know how many, anybody knows what a separately derived system is? Separately derived system. I'm going to postpone this one into next quarter. I'm going to tell you an example of separately derived system, a generator, separately derived system, a transformer that you create your own neutral is separately derived system. So UPS is a separately derived system. So, but please leave the separately derived system until we get into the commercial industrial later on. So I'm not, since we're highly unlikely you will encounter a separately derived system in residential. So supply source and the final branch circuit overcurrent devices. So the conductors between the service and the final overcurrent protection devices, which is the panel, where the panel are located. Questions about feeders? There are 3 types of circuits in the NEC code book defined. If you don't understand them, guys, you are doomed. Not doomed, but you're in trouble. The first one is the feeder, the second one is the branch circuit, and the third one, my friend, is what do you guys think this conductor would be? Service, entrance, conductor. Service center conductor. That's it. 3 types of circuits based on the NEC code book. There is a service, bring the power to the building, and there is the feeders that take the power from one panel, distributed to multiple panels in the building. And there's the last thing is the branch circuit, which is the one that goes from the last overcurrent protection device right here in the panel all the way to where you digest, consume the power, right? You digest and consume the power. Any question, guys, about these 3 circuits? Service, entrance, feeders, and branch circuit. Okay, so that's another thing that we need to keep in mind. Okay, load. When we size the conductors, and I'm going to walk you guys through 310.15b16, which changed her name after she got married. I'm going to walk you through how to use it, but generally speaking, you cannot load a conductor more current than the conductor is rated for. Must not be less than the rating of the overcurrent device. That conductor, the current carrying capacity of a conductor must not be less than the rating of the overcurrent protection device. For example, and we will do this one in details, guys. Here's my overcurrent protection device, 20 amp. You and I know what conductor do we need here with 20 amps. Number 12. My conductor is 15. What wire size do I need with 15? Typical. These are typical residential, guys. Typical. Number 14. Okay. So I have a conductor, an overcurrent protection device, 30 amp. What conductor do I need with this? Number 10. And all these are coming from 310.15b16. So what they're telling you is you cannot put an overcurrent protection device on a conductor that allows the conductor to be loaded more than what it's rated for. So for example, can I go and take this 20 amp and call it all of a sudden 30 amps here and put it on a number 12? No. There's exceptions though, which is coming. Exceptions are motors. A couple of motors and equipment is an exception. So please pay a lot of attention to an exception later on. When you guys come with me, you're going to see that I have 50 amps connected to number 10 and tied to a motor. Look at that, 50 amp tied to number 10, but number 10, Chad, you said it's 30 amps. This is only exception, only okay on motors and a couple of other equipments. I promise you, when we go to 310.15b16, guys, I'll walk you step by step how to use this table. That's the single most important thing. if you haven't done it yet, is how to use table 310.16. 310.15b16. Any question guys about this? But generally speaking, you cannot put an overcomputation device or conductor that allow the conductor to be overloaded. Later on, when you go with me, guys, we start talking about short circuit rating of the conductor. Right now, it's just overloading the conductor. Good example, the rating of the circuit. Look at this is the most common mistake, guys. Look at these. The rating of the circuit breaker is the rating of the circuit. So when I say a 100 amp branch circuit, 100 amp branch circuit, this means the overcomputation device ahead of it is 100 amp. Does it mean the conductor is a certain size? No. The rating of the branch circuit is the rating of the overcurrent protection device. Example, let me tell you, here's 1, 2, 3, 4 branch circuits. This one, I have number 14. This one, I have number 12. This one, I have number 10. And this one, I have number 8. Please write these down because between these 4 branch circuits, that's all what you need. All what you need in the apartment building that we have for branch circuits. So, Phil, my friend, you're going to either be 15 amp, you're doing 15 amp lighting circuits and convener receptacles, or you're going to be at 20 amps. By code, you have to force to do 20 amps in certain applications. Kitchen is one of them. Or you're going to be at 30 amp on an air conditioning, or you're going to be a 40 amp on, anybody remember what typically in a house is a 40 amp? Range. A range. So if you write these, you're done with circuiting. Remember, we're going to be circuiting. So let me just say this one, just add this one. This is range. If you guys want to write range next to this one. This one, so that's my range. This one is going to be your AC unit in our project. This one is going to be certain receptacles. This one is going to be light and recept. So the 15 amp is going to be light and receptacles, general. 20 amps is going to be certain receptacles specifically stated in the code. For example, the kitchen, 2 small appliances circuits, the laundry is a good example of that one. 30 amps is going to be all your air conditioning that you're going to be installing, guys. 99% of the time in the residential is going to be 30 amps. 40 amps is going to be your what? Your AC. 50 amps is not commonly used in residential. Not commonly used in residential. Any question, guys? Any question? So when I talk, Kristen, I say what I have a circuit that feeds the air conditioning. What is the rating of this circuit? You're going to say this circuit is a 30 amp circuit. So the 30 amp, it goes by the rating of the circuit goes by the rating of the overcomputation device. Any question? Let me tell you an example why things make a difference. Why can't I call this circuit number 14 circuit or number 12 circuit? Can I call it number 14 circuit, number 12 circuit? No, because the conductor has changed. The overcomputation device is the most important thing in the circuit. So let's take an example. Take this. This is a 20 amp, and I'm going all the way to a parking lot light, and I'm feeding all these parking lot light. This is L, 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 L. We don't have a parking lot light in this building, but later on you're going to do it. Here's a 20 amp circuit, and because of voltage drop, I'm going to be using right here number. Let's go now. Actually, number 6. Look at this. It's a 20 amp circuit, but I'm tying to it number 6 conductor. Why do I do that? Because of voltage drop. So what's the difference between this 20 amp circuit and this 20 amp circuit? Nothing. Both of them are 20 amp branch circuits. One of them, because of voltage drop, I oversize the conductor. Questions? Any questions? See why they go by the size of the overcomputation device, not by the size of the conductor? Why would you do something like this, a number 6 and 20 amp circuit? Come in and practice. You're going to do it in parking lot and so forth. Voltage drop. You oversize so you don't lose. You start with a 240 volt. You don't want to end up with a 200 volt on the other end. So your light wouldn't work, and if it works, it would malfunction, and if it works and it doesn't malfunction, it will die prematurely, right? Equipment either doesn't work when you give it low voltage, or if it works inefficient, or if it doesn't, or it die on you prematurely because of under or over voltage. Any question guys about branch circuits and wire size? I can't emphasize, Dustin, my friend, writing these, please, because these are what you're going to be using as branch circuits. Between number 15 to 40, that's, guys, all these branch circuits I'm going to be using in this project. Any question? Any question, my friends? 310.15p16 is the single most important table. As I said, she got married and she changed her name. It used to be 310.16, now 310.15p16. I promise you, later on when we go through this book, I'm going to be walking. The first thing I do when we start sizing, I walk you through how to use 310.15p16. I know you've seen it before in the first year and all this stuff, but I want to give you my 2 cents on how to use this table. Okay? I'm going to give you a couple of hints. What I gave you before, guys, all these conductor sizes that match the overprotection device, that's coming from 310.16. So be aware of that one. Correction factors. Later on, guys, and I'm sure we use some correction factors. We're going to be doing some correction factors based on temperature and bundling. For example, you're looking at 1/2 inch EMT conduit here. What if I stuck 10 number 12, well, let's say 8 number 12 conductors stranded copper right into this one to feed multiple things? Then these conductors cannot carry, number 12 cannot carry at 20 amps anymore. You have to derate it. So that's what we're going to be doing in residential, and not a big deal. But we go commercial industrial, derating becomes a big deal, guys, because bundling meaning saving money. If I have a 3/4 inch right in here, guys, 3/4 inch coming from here, carrying 12 conductors, number 12, 12 conductors, number 12, I can, with this, I can, and 277 voltage, I can feed close to 300 lights from a 3/4 inch, 3/4 inch conduit with 12 conductors, 3-phase system, 277. Remember, the voltage is high. We will do this in a commercial, so bundling become a big deal when it comes to the commercial industrial. But we will touch into the derating factor and how to do it. And I know you guys have done that, a few things with Gary, right? Did you do it? And you guys, I know that, but with this, I will do a couple of examples as we go too. The code says if you have 3 hot conductors, you have to do it. If you guys remember, either by bundling. If you have 3 can conductors, you have to do it. And we have the tables. In 2011, they changed where the tables are located, 310.15b3a. That's where you're going to be derating based on bundling. They call it bundling. You derate based on 2 things, temperature and bundling. Temperature and bundling. And again, we will get back to these and do calculation based on these tables. So please don't sweat it too hard. What happened in 2011, guys, they changed the names of all these tables. They slightly changed the names. A couple of things back into the loading, guys. Most general use receptacle outlets. In residential, here's what I want you guys to do. Tell that to my brother-in-law. He's going to be listening to this. In dwelling, you're going to be using 15 amps and 20 amp circuits. My advice for you, 20 amp circuits going to go with number 12, 15 amps will go with number 14. You have a lot of people who say, Chad, I'm going to make all my house number 12. You're wasting money. Really, for convenient receptacles on light, if you use more than number 15 amp, number 12, you're wasting your money. For this project, here's what we're going to be doing. We're going to be follow the code by you're going to use 15 amps unless the code is asking you otherwise. Unless specifically the code says a 20 amp circuit, for example, the kitchen, you're going to be using 15 amp circuits. Did you guys hear me? Because you're in my book, and I'm the authority having jurisdiction here, as you guys know, it's overkilling to use a 20 amp circuit, for example, in dwelling. Did you guys hear me? Not here. To feed the lights the lights in the hallways and in the kitchen and so forth. So We have general light, general use receptacle outlets, and we have the 20 amp small appliances branch circuits. We will talk about this one in a second, guys. The load calculation, which you guys will be doing based on this table. Based on this table, we're going to be doing, and I'm not going to do the calculation now because you will be doing it for the project and for our calculation too. The code allows 3 volt amp per square foot for general lighting and general purpose receptacles. That will cover almost all the lights and almost all the receptacles except specific receptacles or lights that's allocated in the code. And I'm gonna walk you guys step by step how to do the calculation, what counts as part of 3 volt amp and what's not part of the 3 volt amp. So leave this one to a different presentation, but I want you to know that 3 volt amp per square foot, this counts for receptacles, general purpose receptacles, and for general purpose lights. It doesn't count for the air conditioning. It doesn't count for the microwave. It doesn't count for example, the air conditioner, microwave. Give me another not dishwasher. If you have a garbage disposal, not counted for garbage disposal. It doesn't count for dishwasher, doesn't count for dryers, doesn't count for range. See these equipment? These are allocated equipment, they're all loads. It also doesn't count for the 2 small appliances circuits in the kitchen that we're going to talk about in a second, as well as the bathroom. These have their own calculation. Other than that, everything is calculated within this 3 volt amp. So how do you use the 3 volt amp? Chad have a 3,000 square foot house. You multiply this by 3 because the code says 3. You're going to end up with 9 and 0, 0, 0 volt amp. This is how much volt amp, calculated volt amp, not connected volt amp. Your expected, this is by no means a scientific calculation, by no means, expected from a design point of view to allocate for the lights and the receptacles, convenient receptacles and general purpose lights. Does not include a lot of things. That includes all your lights in the residence, all your lights almost, and that includes all the general purpose receptacles in the residence. Does not include the equipment and does not include the bathroom, does not include the laundry room as well as the kitchen. All this calculation is coming, guys. Any question about the load? I'm interested here in the branch circuit. You're going to hear continuous load. Let me tell you something about continuous load. Continuous load, guys, in residential, continuous lights and receptacles are assumed non-continuous in residential. The code doesn't tell you that, but it's highly unlikely that you can argue probably with me here. But from a design point of view, lights and receptacles, if they are used in a dwelling units, they're assumed non-continuous. Highly unlikely they're going to be fully running. All the lights are on the same circuit for 3 hours or more. Again, you can argue with me and sit and say, no, in my house I turn everything on in every room and leave it for 5 hours, that's fine. But for practical design view, it's not continuous. Sister.
So, our TVs and appliances, electronics, they suck some juice, and that's continuous, but is continuous meaning full load?
Full load. Okay. Continuous means 3 hours at full load. Example, very good point. I have a 20 amp circuit, right? 20 amp circuit, or no, 15, like the one I'm going to be using for your convenient receptacles. I have 15 amp. I have a bunch of receptacles here, bunch of receptacles here, bunch of receptacles here, and also I branched in here and they have light, L, R, right? Typical in house. Mixed, they're mixed, right? So for this circuit to be continuous, you need to suck 16 amps out of this circuit. I'm sorry, 12 and a half. I'm thinking 20. 12 and a half amps, which is 80%, 12.5 amps. If the whole circuit, not your microwave is on, the whole circuit, if the whole circuit is sucking 12 and a half amp out of that circuit breaker, then it's continuous load. Now here's what happened. Your plasma TV is sitting right in here and fit from this receptacle, and it's taking 1 amp. And it's there for how many hours? all the time, Chad. I like my plasma TV running all the time. CNN is there or other things. Remember, it's only 1 amp. While this circuit breaker, this receptacle is dead. Dead. This light is off. So what's the likelihood that all these receptacles will be, things will be plugged in at amp to add up to 12.5%. That's why we consider it non-continuous. Does it make sense, guys, the term continuous? Continuous circuit, you're going to pull 12.5 amp percent to reach the point of full rating for this 15 amp circuit.
Is the point of this to avoid heating up the conductor?
Thank you. The only thing.
Conductor starts to get too hot.
Absolutely, absolutely. The point of, if it's continuous load, guys, it runs 3 hours. It doesn't allow the conductor to cool down. But if you can run, so take this, Chris, take 12.5 amps for 2 hours. 2.5 hours. For 2.5 hours, you can take 12.5%. Actually, you can this is for 3 hours. Actually, I don't want to go there. For 15 amps, for say 2.9 hour, and I'm being smart aleck here. For 2.9 hour, I can pull out of this circuit breaker 15 amps. 2.9 hours. The minute that I switch to 3, I have to go back to what? Cut it back. Why? Because if you take 12.5 out of this, you're meeting the 80%. Remember that 80% of it? Now, by doing it this way, the conductor will not overheat. It's all about overheating. If the circuit is continuous load, feeding continuous load, you always take 80% of it. Example, I have a 100 amp panel and every single load fit from this panel is continuous. How many amps you can utilize out of 100? 80% of it, 80. I have a 100 amp panel and every single load here that's fit from it is non-continuous. How many amps I can utilize out of that? 100 amp. Please put this in your mind. And when they say the circuit is 100 amp, what does the circuit 100 amp means? The overconduction device ahead of it is 100 amp. Any questions about continuous load? Actually, for all practical reasons, residential are non-continuous loads. Because yeah, you have plasma TV is on, but you turn everything off in the process. Okay, they have, if you guys go to this article, this will list all the voltages that are approved by the NEC code book, 120 volt, 240 volt, various voltage values to use different electrical systems. For residential, in this project, we're going to be using these 2 voltages. If you guys go there, you're going to have 480, 277, 600, 340 something. You're going to have 208, 120. All the common voltages which we will be using through the year are listed over there. The voltage that we're going to be using here in this project is 120, 240 single phase. 120, 240 single phase. So this is, we call it 240/120 volt single phase 2 Hz. These voltages are called nominal. What does the word nominal means? Nominal means is just a name for it. If you actually, and you do electrical work, if you go measure the voltage, would you find exactly 240 across 2 Hz? You probably will find 243, 250 sometimes, 237. So you can go up within, most of the times, guys, most of the time you're going to be within plus or minus 10%. Don't want to go to the end. So but everybody knows what a nominal voltage. So if I have 120 volt here, most of the time you want to be within, probably for this voltage, I hate to use this, but plus or minus 10%. That's the extreme 10%. The extreme plus, everybody knows plus or minus. The best design, that's the extreme. Best design probably plus or minus 5%.
Is it 65 a typo?
With 65%. Voltage for residential services be held at 65 of the nominal voltage, yes. Where did they get that 65% of the nominal voltage? 65, they will give you a
78 volts.
No. I wonder if what they get that one, 65%. Here's the fluctuation. This is a good, within the 5%, guys, is good. Extreme, you don't want to get the extreme. Extreme is plus or minus. Utilities maintain them. So everybody knows what the actual nominal is. Just a name. Actual is when you grab your meter and you go plug it right in here, you're going to find most of the time lower voltage because of voltage drop. Most of the time. Any question, guys, about the voltages, nominal voltage versus actual operating voltage?
How is the voltage controlled kind of down the line? To try to get that 5%.
Oh boy,
That's it.
it's a whole lot of how the utilities control the voltage to stay within this. They have capacitors and reactors and transformers and tabs. It's a topic. Let's open this topic when we go into the industrial, would you? But believe me, they have a lot of stuff that they can control it. Caps is a big deal. Okay, rules for load calculation 220. Again, I'm not going to do the 220, guys, because I promise you we will be doing a whole lot of calculation in it. And we're using our calculation based on the standard system. Occupied areas is the total. When you take the square foot of the house, I think we have okay, we don't have it. When you take the square foot, guys, of the house, you take the finished space only, and anything that could be finished in the future. For example, if you have a basement and that section of the basement could be finished in the future, you have to include that section in your calculation, the square foot. Remember that Chad's house, the 3,000 square foot? How did you measure this? Outside diameter and based on the finished space or anything that could be in the future finished. So obviously your garage is not going to be finished in the future, so you can sleep on it. That will be excluded. Crawl space it will be excluded. Mechanical area where you have, I don't know about you, but you're not going to finish the laundry room downstairs and the mechanical equipment and sleep there. I guess you could, but highly unlikely you're going to do that. That's unfinished. But other than that, if you have an open area in your basement that could be finished in the future, you include that one. Any question, guys, about what's included? Everything finished or everything that could be finished. Now, Chris, I know you are kind of a programmer, kind of black and white. Now, how do you draw the line between that one? You're going to lean on the side of safety. If anything could be finished, based on your judgment, you're going to use it. It's a human being judgment. So your judgment and mine might differ sometimes. And ultimately, who's to this? Well, in design, not a big deal, but who's to decide ultimately, guys, and all who's right and who's wrong? Authority having jurisdiction. Okay. Porch, garage, other unfinished spaces are not calculated. We multiply, we'll do that. Track lights. So we know what's measured, and again, you guys are going to be measuring the apartment, and you will be measuring the finished space in the apartment and multiplying it by 3 volt amp and find how many volt amps you need. Exclude, as I said, the porches, unfinished spaces that can be used in the future, and garages are not. You exclude them from the calculation. Swimming pool. Do I need to take the square foot of the swimming pool? You guys can have garages and swimming pool. When I say take the square foot of the building, are you going to go take the garage and the swimming pool too? No. Track lights. Track lights are weirdos. Track lights, if you guys, based on the code, if you use the same track light, you use them here at Dunwoody and put them right here, you have to account for the volt amp of the track light in the calculation. The same track light, take them and put them in your house, you don't have to account for them. Now remember, track lights are not general purpose lights. If you have a track lights, most of the time it's certain aspect light. It's not a general purpose light. If you put the track lights in here, Dunwoody, you have to account for it, and it's not part of the 3 volt amp or whatever for 3.5. If you put it in your house, it's already accounted for. So that's what this slide is telling you guys. It's part of this 3 volt amp. Any track lights that you put in there, you don't have to account for them. If you're putting a track lights, obviously you don't want to track. The light track shall not exceed the rating of the track. I mean, if the track says 4 amps or 15 amp track, you don't want to put a 20 amp circuit in it. Any question, guys, about track lights? We don't have track lights in the project, but if you were to have a track lights, you don't have to add more volt amps. It makes more sense. Did you guys do load calculation for commercial industrial, Gary? Did you start the commercial industrial load calculation? Okay, if you haven't done that, it doesn't make a whole lot of sense. Later on, next quarter, we're going to have a track lights in our commercial building, and I'm going to ask you to find a volt amp for this track lights and assign a certain amount of volt amp for it.
And connected load on a track like that, basically saying you can't screw more bolt in it than the thing.
Then, yeah, everything is, then, yeah, absolutely. You can't,
I don't know how you violate other than doing that.
yes.
Is there a way to not do other than putting larger bolts in it?
All of them have a rating, how the largest what that you can put and how many heads that you can put in this track
And
lights.
then they have little, you know, protection devices, like if you are gonna put up another one,
Heat.
it's
Heat.
an optional thing, and you can put it on into the track and then just trip it. You can't do that.
If you're overloading it, it will
Right.
trap. Yeah. Okay, moving on, guys, to a small appliances branch circuit. Two things about small appliances branch circuit. Please, if you don't know that, highlight it. Small appliances branch circuit, you need two branch circuits. This is number one. And these are for the kitchen and the dining room. And you allocate 1500 volt amp for every circuit. So, Phil, my friend, you get into your kitchen, at least you need to have 220 amp circuits that feed all the receptacles in the kitchen and the dining room, if any. You can have two, at least two, and they're all 20 amp circuit. And if it's 20 amp circuit, what do you need with them? Number 12. Number 12. That's a must. That's a place where you have to use number 12. You have no other option. Number 12. Any question, guys, about this? So two things here. For the kitchen, you need two circuits, 20 amp. So when I start, when you guys start designing your kitchens right now, we're going to put two 20 amp circuit, loop all the receptacles on them. By the way, the code also say, Phil, these two 20 amp circuits, they have to pass through the countertop, both of them. So don't be smart and go put one circuit on the countertop and the other circuit around the room. You can't do that. Both of these two circuits have to pass through the countertop, both of them. What we have done, guys, what I've done when I wire them, you use 14, anybody who wire, we use 12-3. 12-3, and you come to receptacle number one, feed it from circuit one, circuit two, circuit one, circuit two, and you loop it around the whole house. Very easy, shared neutral, done deal. Any question, guys? So the kitchen now, here's one special circuits, two circuits for the kitchen. And when you do your calculation, remember Chad's 9,000 volt amp that we just calculated? You're going to add the 15, going to multiply it by 2 and add it to the 3,000 amp that Chad have just calculated for his house. Questions? This is, you have no other options. You have to put two 20 amp circuits. So that's it. So 20 amp circuit, kitchen, and so forth. So here's the 220 amp circuits for the kitchen. This is my 220 amp circuit. The other area that needs also a 20 amp circuit is what? 20 amp circuit for the bathroom, and the laundry room, guys, also need a 20 amp circuit. By code, these are the only three places that you must use a 20 amp circuit. You can't get away with number 14 or a 15 amp circuit. Okay, one more time. Here's a two here for the kitchen, one for the 20 amp. All these are 20 amp. One for the laundry and one for the bathroom. Yes, sir.
Don't the outside GFI outlets have to be 20 amps as well?
Optional.
Oh, so man,
Some people do. No, you don't have to. The only 20 amp circuits by code have to be the kitchen, the bathroom, and the laundry. All other receptacles, number 15 amp. Now, can I put them 20 amps, other receptacles? Yeah. It will be, in my book, it will be overkilling. Guaranteed.
You know how you just mentioned the on-site GFCI receptacles? Where does the code talk of, you can move from inside to outside?
Yes. As long as you don't tap from a kitchen circuit, a bathroom circuit, or a laundry circuit.
Okay.
See the point? And by the way, Phil, my friend, and Rob, you see these three places? I call them sacred cows. These circuits, you cannot tie anything, feed anything out of these places. So the circuit that's coming to the kitchen, the only area that's allowed in the kitchen to be fit for the kitchen is dining room. That's all, dining room and kitchen. For the bathroom, can I just steal 20 amp circuit and go feed the receptacle in the bedroom? You can, but it's against the code. Can I go to the laundry room and sneak poke right out and go feed the receptacle outside from laundry room? No. You can. I've done it. if it's not going to be inspected, it works, but it's but based on the code you can't. I hate it when people look, act like angels. We all done it. It's so easy. You have a receptacle right here, and they need a receptacle on the other side. Take that one out, drill through, move in. Well, oops, this wasn't a countertop door. So that's violation. If that receptacle was countertop receptacle in the kitchen, anywhere in the kitchen, or if it was anywhere in the dining room too, or if it was a laundry or bathroom, no. I call them the sacred cows. Okay, questions? 15 amp branch circuit everywhere else. Everything else is 15 amp branch circuit. Everything else, you're going to throw it 15 amp branch circuits. 15 amp branch circuits. Any question about that? 15 amp branch circuits. So that's it. Other than these, and remember, these are receptacle. Later on, Zach, we haven't talked about equipment yet, have we? We haven't talked about equipment like in dishwasher, garbage disposal. Let me give you a hint. All equipment 20 amp circuit unless it takes more. Don't use 15 amp circuits with equipment. Equipment is a very good idea to use 20 amp circuits or equipment. And when I mean equipment, some pump, garbage disposal, dishwasher. Give me another. Exhaust fans. Major exhaust fan, like not in the bathroom. There's exhaust fan in that apartment building, right into the utility room. You're going to see it. So unless they tell you otherwise, it's 20 amp if it's an equipment. Any question, guys, about that? That will help you guys lay out your receptacle as we go through, right? Hopefully. Now, 15 amp circuits. 15, you're going to do all your receptacle as well as all your lights. All the receptacles and all lights, 15 amp circuits in this apartment. All receptacle excluding these, all lights going to be 15 amp circuit number 12. Number 14. Any question, guys, about these circuits? I can't emphasize because you guys are going to be laying out your receptacle and circuiting right now. The question becomes how many lights? Anybody came up with how many lights I'm going to put in the circuit, Chad? Right? Now, I know here in the bathroom it's easy. It's going to be only one receptacle. By the way, the bathroom is an exception. You can feed the light in the bathroom from the circuit that feed the receptacle in the bathroom. It's okay. In the kitchen, I can't feed the light in the kitchen from the same 220 amp circuits, excluded. So you guys know the same thing for laundry. The laundry receptacle, you can feed other receptacles in the area from it, but you can't feed the light in the area. The only place that you can feed lights in the bathroom. But for this project, I don't want you guys to do that. So the bathroom light, as well as the light everywhere else, is going to be separated from the receptacles in this project. Good idea. That's what we do in commercial. It's a good idea to do it, regardless of what the code say. Okay, lights and receptacles. How many lights, how many receptacles? Because these are non-continuous loads. These are non-continuous loads, guys. Your limit is really for the 15. If you're using, I'm going to say on a 15 amp circuit because I don't want you to use for convenience more than 15 amp circuits. In the 15 amp circuits, when we go commercial, guys, we use basically 15 or 20 times continuous load commercial times 0.8 times 120 divided by the volt amp of all the lighting fixture. And that's how we calculate them. Most of the time for lights, you end up with close to 11, 10 lights. Receptacles, you can put up to 9. A lot of designers limit it to 6. We'll talk about these rules as we go to the commercial. For residential, guys, you can, on a 15 amp circuit, you can put up to 9 lights or receptacles. 9 lights or receptacle is a good number to put in a 15 amp circuits. Up to 9. You can. It's a good idea to split them if you have, for example, if I have a 10 receptacles, Phil, can I throw that one on one circuit? Yeah, it's a good idea to split them 5-5. You know what I mean? Up to 9 if you have to, squeeze 9 on them. You really, practically, you can almost put 15 on a 15 amp circuit. 1 amp for each receptacle or lights, because the lights in residential, they don't. Let me just give you an example. Take this. Here's 120 volt. The current is I. Divide by the watt, 100 watt. If you have a 100 watt lamp in your house, 100 watt lamp, if you divide it by 120, the voltage, that'll give you 1.2 amp. 1.2 amps, right? Just the simple math. So 1.2 amps, if you multiply this by 10 lights, that will give you 12 amps. 12 amps with a 15 amp circuit breaker is a good idea, not a bad. So you can put 3 lights, 12, 10 lights on, if the lights are 100 watt. And most of us right now are moving to less than 175, and the compact fluorescent is even less, 23 now. So that's why I thought when you go 9 lights, guys, you're good. Up to 9 lights. Shall we do that for our design? 9. Really, in reality, if you can almost throw 15 on it and move on. 9 lights are receptacle for convenient, unless you're told otherwise. Questions about that? So we know how to circuit. Start throwing receptacle up to 9. 1 circuit. 10, split. 5, 5. Yes, sir.
Why did you multiply 10?
I have 10 lights.
Oh,
I designed 10, that's CSP. I put 10 lights. Yes, sir. Thank you, Phil. I know in commercial industrial we don't do spaghetti. For this particular project, I want you guys to do spaghetti. I promise you when we go to commercial industrial, we're not going to do spaghetti. We're going to identify the circuit, the type with the fixture and all this stuff. But for this one, I really want to get the spaghetti. We're going to print with spaghetti. I know the ones who are used to the commercial, they hate the spaghetti. But I have my reason why, guys, because we're going to be takeoff and doing takeoff, and it's easier to understand it. So blame it on Chad. If anybody complains, blame it on your friend Chad.
Just a quick question.
Yeah.
For the lighting circuits, now is that or is that not considered continuous?
Non-continuous load.
Non-continuous.
Yeah.
Because residential is non-continuous.
Non-continuous.
Right.
Yeah.
So we really could
Yes.
load that up.
Up to 15 amps. I guarantee you. It's not a good design though. Remember, you are planning, yes, you're planning a future. So you allow them, if you put 9 right now in the circuit, you allow them in the future to add another 4 or maybe 5 lights.
But then we can argue about what you said with CFLs and LEDs and all of it.
Yes, yeah. If you put, you want to do the math, let me tell you this math. Do this math here. Take 120 times 15 divided by 23 watt. Do this for me, will you? 120 times, these are compact fluorescent. See how many compact fluorescent you can put in a 15 amp circuit in a residential. How many?
78, I think.
78?
That's right.
78? 78 compact fluorescent you can put in a 15 amp circuit. Do you really want to do 50, 78? 60, 50? That will be your house and your neighbor's house in one branch circuit.
that's what you're growing around.
Oh. So see what I mean? If you want to go to the compact fluorescent, how high? It's a good idea, guys. Hovering around 9 allows you future expansion. And at the same time, it's a good compromise. Cool? Good? Okay. Provide minimum requirements. For the receptacles, guys, we're going to provide minimum requirements. Here's the minimum requirements that you need. In habitable rooms, I'm sure you guys have heard that one. Habitable rooms, anything that's habitable, including the kitchen, you have to have a receptacle within 6 feet. Example, here's the door here. This is my bedroom. The door, you start from here, measure 2 feet and 4 feet, put receptacle 1, move 12 feet, receptacle number 2. Obviously, you don't want to go exactly 12 feet. So these are kind of the extreme. So when you put your receptacle layout, the rule is 6/12 feet, not inches. Feet. Okay, everybody know the rule? All habitable areas, excluding unfinished basement, garage, outdoor, excluding bathrooms. These are non-habitable, including all bedrooms, living rooms, kitchens, hallways. No, hallways are exception. I'm sorry, hallways are exception because you don't you don't put your bedroom in a hallway. Any question, guys, about excluding stairways? Everybody knows that rule, 6/12. Another rule, when you lay out your receptacle, convenient receptacle, 24 foot or more. I have a wall, and my wall is 2 feet or more. I need at least 1 receptacle. Okay, cool. Phil, we looked at your stuff the other day when we measured it. 2 feet or more, you need to put a receptacle. These are convenient receptacles. So Rule number 1, 6/12. Rule number 2, 2 feet or more, one receptacle. One receptacle. Okay, now moving into the kitchen, this is just walls. Moving into the kitchen countertop, guys, a kitchen countertop, any space of 1 foot or more, you need a receptacle. Countertop, a space of 1 foot or more, one receptacle. The rule for the countertop, again, I can't emphasize, we're talking about countertop here. The rule for countertop is 2 by 4. Very easy to remember. Everybody knows 2 by 4, right? 2 by 4 is the rule of the receptacle. What is 2 by 4 is? It's like 6 by 12. 2 by 4 is 2 from the edge of the countertop, 2 feet with receptacle, then move 4 feet, receptacle, 4 feet, receptacle. Way at the other end, or the other edge, or the sink edge, you can't be more than 2 feet. 2 by 4. Cool? 2 by 4, the rule of 2 by 4. So for example, here's my sink here. My sink, here's my 2 feet, put my first receptacle, and 4 feet. This will be 2 feet, 4 feet, and then from here to here, I can't go more than 2. Let's go to, then switch the other side, 2 feet, put one receptacle, 2 by 4, yep. 2 feet, you put your one receptacle. At any point, the kitchen should not be more than 24. Yeah, 2 feet, and then move all the way up to here, another 4 feet, with your first receptacle, and then you need, so let's say this is 4 feet, was another receptacle, and from here to here, it has to be 2 feet. 2 feet by 4, everybody knows a 2 by 4? 2 by 4?
Are mini bars and things like that considered like a kitchen?
Bars, if you have a bar 1 by 2, you have to have a receptacle. There's a example about it. Okay, here's an example. Should have came over here, guys. Anything, if you have 2 by 1, you need at least one receptacle. 2 by 1, you need one receptacle. In the peninsulas and islands, right? And then start from here. Here's your 2 feet, here's your 4 feet, 2 feet again, 2 feet, 4 feet, 4 feet, 2 feet, and this one, if it's a foot or more, you need a receptacle. Any question, guys, about this? Any question about this? Kitchen countertop, 2 by 4, the rule 2 by 4. 2 by 4.
So if that island is bigger, let's say
One receptacle.
4 foot.
One receptacle.
Per peninsula.
One receptacle, regardless. It could be as big as this house. One receptacle. at this room, one receptacle. Yeah. Okay, all these receptacles have to be what? GFCI. They have to be GFCI'd. Receptacle, well, there's 2 ways of doing GFCIs. You can put a GFCI receptacle here and feed them all, one way. You need 2 of them, right? Because there are 2 circuits. Or you can put each one of them as a GFCI. Or you can put the first one GFCI and feed through the rest of them GFCI protected. Whatever you do, guys, you need 2 circuits here. Let me just bring to your attention. This is also, this is 4 feet, 2 feet, was 2 feet part of it. I think this is a closet here. Okay, suppose this is my kitchen. I'm going to circuit this. Look what I'm going to circuit this. Just the kitchen. I bring my home run here. Well, one way of doing it. One way of doing it. One way of doing this circuiting. Let's see. I'm going to start with the fridge. I'm going to tell you why I'm going to start with the fridge with my home run. Here's my fridge, and I'm going to go feed 1, 2, 3. This is circuit number 1. Circuit number 2, I'm going to start circuit number 2 here. I'm going to go feed these 2, and then grab this, go back to this, go back to this, and go back to that one. So if you do it this way, this one, do you want a GFCI on the fridge? No. So your first GFCI could be here. GFCI. This one GFCI. Everything else is protected. and this one GFCI. Everything else is protected.
They make a big deal in the book about not putting the fridge on the countertop.
You can, but yeah, it's a good idea, good design to throw a circuit. You're allowed to throw an extra circuit 15 amp for the fridge. The code says permitted, permitted. So if you guys want to go take a fridge and have a circuit for it, that's fine. I think it's personally, if you do 220 amp circuits in a kitchen, you know what 220 amps are, how much power you can, how much juice you can get from 220 amp circuit. If you do it right, I think you're good. Yes, unless you have really a huge house and you entertain a lot. And yes, sir.
Would you like, if the kitchen was close to the garage where you had, a freezer, could you throw?
Kitchen is a sacred cow.
Okay. All right.
No. You can take the dining room with it, but other than that, no.
What do you suggest about freezers?
Freezers in where?
Garage.
In the garage. You have a freezer in the garage. The garage by code, you have to have one receptacle for the garage. If you have a general purpose garage, you don't do a shop there. A general purpose garage, if you have a 15 amp circuit, honestly, and you feed one receptacle general purpose and one for the freezer there, both of them have to be GFCI by code, you're good. But if you are a handyman and you do a lot of work there, it would be nice to throw two circuits there. One, if I am to wire my garage, I will put more than one receptacle in the garage, definitely. And I will put at 20 amps in the garage because I do a lot of work. So you put 220 amp. I will put two in a garage if I want to wire it, not code. I would 220 amp circuits and feeding the multiple, at least two receptacles in every wall in the garage, and divide them between two circuits. One of these receptacles will feed the freezer. But code-wise, one circuit. You don't even have to have a circuit. You can put your good design though. It's good designs to have one circuit for the garage at least and feed it. One receptacle convenient, one for your freezer. Any questions about this? That's typically what you're going to be circuiting. Almost there, guys. 15. Another thing, countertop has to be all GFCI. If you have you have a bar in your basement, any receptacle within 6 feet, where is the 6 feet? Any receptacle within 6 feet of a sink have to be GFCI. So a bar in the basement, any receptacle on the countertop of the bar, that bar within 6 feet have to be a receptacle. Exception, a lot of people, I don't like to do that one. Take this. I have a wall. Suppose I have a wall right here. Just suppose I have a wall right here. Well, where is the sink? Suppose I have a receptacle right here, and this receptacle is within 6 feet, and it's not on the countertop. See where this receptacle on the floor. If a receptacle is not on the countertop in a kitchen, and even within 6 feet, it doesn't have to be GFCI. Kitchen sink is exception. But if you have right here, look at this. See that? If I put a receptacle right here, this is wet bar, not a kitchen, and that receptacle is 6 feet from this wet bar, but it's not on the countertop, just on the wall. They have to be GFCI. Okay, so all these have to be GFCI'd. I don't need to put receptacles on a wet bar in my basement. Do I by code? It's a wet bar, it's not a kitchen. I don't need receptacles, but if you put a receptacle, which you should be smart enough to put one or two at least, they have to be GFCI if they're within 6 feet of a sink. I didn't talk about equipments, guys. Equipments, you always give them a dedicated circuit. We'll talk about equipments. Any dishwasher, washing machine. Washing machine is part of the laundry, but dishwasher, garbage disposal, 20 amp circuit, dishwasher, 20 amp circuits, sump pump, 20 amp circuit, exhaust fan in the common area, 20 amp circuit, and so forth. Unfinished basement, all the receptacles, unfinished basement, outdoor, and in the garage or crawl space have to be GFCI. Everybody knows that? All have to be GFCI. In the bathroom, countertop kitchen, wet bar, unfinished basement, outdoor, garage, all have to be GFCI. And all the receptacles by code have to be two things. They have to be tamper-resistant. Everybody knows all the receptacles by code right now have to be tamper-resistant everywhere. Tamper-resistant receptacles must be, they're $1.30 versus 33 cents. All receptacles, and all receptacles have to be arc full circuit interrupters protected. All the brand circuits have to be arc full circuit interrupters except the following. Arc full circuit interrupter, guys. Except the following. Bathroom, anything in the bathroom, excluded. Anything in the kitchen, excluded from arc fault. Anything in unfinished basement, excluded. Outdoor, excluded. Garage, excluded. Other than that, every single circuit in your house in residential have to be arc fault circuit interrupter. You guys are going to be listening to a presentation in a few seconds about that. So where do you need them in the house? Everywhere, almost everywhere that you don't need a GFCI. Just think about it. Everywhere that you don't need GFCI. In the kitchen, you don't need a GFCI. You need a GFCI on the countertop, so you don't need them. In a basement, you need GFCI, unfinished basement, so you don't need arc fault. In a bathroom, you need GFCI, so you don't need arc fault. Outdoor, GFCI, no arc fault. Garage, GFCI, no outdoor. Crawl space, GFCI, no outdoor, no arc fault. Does that make sense? And the arc fault, guys, the way that they're coming with the arc fault, I'm sure you've seen them. You have a circuit breaker like this right now, and you put the arc fault circuit interrupter, and you feed all the lights and all the receptacles from arc fault circuit interrupter circuit breakers. Not just receptacles, both lights and receptacles. Any question, guys, about arc fault circuit? We talked about the GFCI, the arc fault circuit interrupter, and tamper-proof. Tamper-proof. All the receptacles have to be tamper-proof, period. All of them, period. Everywhere. Arc fault circuit interrupter, we talked about the places, and GFCI, we talked about where they need to be GFCI. So when you lay out your receptacles, you're going to be thinking, is it GFCI? Or is it arc fault circuit interrupter? But you never question that it has to be tamper-proof. Tamper-proof. The second thing is, if you have receptacles in a wet or damp, in a wet location, you have to have in-use cover, outdoor, as well as weatherproof. So outdoor, this is outdoor. You're going to have the following. In-use cover. Everybody knows what in-use cover is, and weatherproof. In-use cover and weatherproof. So the receptacles that you put outdoor, in-use cover, plug-in cover it, and weatherproof. Weatherproof will run you a couple of bucks more than non-weatherproof receptacles. Any question, guys, about weatherproof? These are new. Some of them are newish.
Where's the tamper-proof come into the code, or what is the code?
Tamper-proof. Where does it code? 404 or 0406. I think 404 that talks about receptacles. Any question, guys, about this? So we got that. The other thing, guys, also front and back by code. If you have single family dwelling, you have to have one receptacle in the front of the house and one in the back of the house. What happens if you have an apartment? I know you know that. What happens if you have an apartment? Like you guys. We have an apartment. We don't have a house. What does this code say about apartments? Here's what the code says about apartments. If the apartment unit in an apartment building has an individual door that opens directly to the outdoor, which you guys, your project has two of them. So basically they have two entrances to the apartment. They can get from the common space stairway in, or they have a door that opens to the outside direct. If you have a door that opens to the outside direct, then you need a receptacle. For the apartments, guys, that we have, I'm asking you to put two in the front and two in the back, convenient. And you're going to add also one, these are powered from the common spaces for holidays and so forth. Good design, no code. But to meet the code, you also, the apartments, they have the slide door that open towards the swimming pool. You're going to see it. You're going to have a receptacle that's fit from that apartment's power system, not the common. So only if you have a sliding door or door that opens directly from the apartment unit, you need. Otherwise, single family dwelling, you need one in the back, one in the front. There you go. Here's what we talked about, one back, one in the front. Does it need a dedicated circuit? No, you can steal the power from anywhere except laundry, kitchen, and bathroom. Sacred cows. These are sacred cows. Almost there, guys. Receptacle, single receptacle, multi-outlet receptacle. When we say a single receptacle, guys, I'll talk about the lights in a second. When they say a receptacle, the code consider this is a receptacle, even these duplex receptacle. This is also a receptacle, single receptacle. And if you put 3 of these on one yoke, this is also a receptacle outlet. It doesn't make a whole lot of sense when we talk about residential. Most of the time use duplex. But if you put a single receptacle, one receptacle and one yoke, that's considered a receptacle outlet. Okay, lights. When we talk about lights, guys, so any question about receptacle, that will cover almost all the receptacles that we do. I have a few minutes before I let you guys go. For any question about receptacles in residential, you need, and circuiting, we know how many, 9 on every circuit, convenient and lights, separate light from receptacles. We're going to have a 220 amp circuit for the kitchen, 1 for the bathroom, and 1 for the laundry. Everything else is going to be 50 amp circuits. Lights, my friends, you need a light in every habitable space. Light in every habitable space. So by code and by convenience. So at least one light. So you go to the living room, Nick, and you said, how many lights do I need in, by the way, here, how many lights do I need here? One light by code. With a switch. And that switch could be a wall-mounted switch or could be a pole chain. So most of the time, guys, you have to have, in all, if you look at this is really nice picture. Bedroom, hallway, bathroom, any utility room, stairway, and so forth. All these places need a light. One light. That light could be wall switched like this, or you could walk to the light and turn it on from the light itself. You've seen it in the basement, we use it. So that's habitable spaces. Outdoor, the door that opens to the outdoor, like the main door, you need a light, obviously. So if you have a door, an outdoor, you require a light here. The garage also require a light. You have to have a light in the garage, in your garage. And if you have a service door, outdoor service, you put garage by code. A good design, guys, is obviously to put it like they're showing here. 1 to the service door, 1 to the garage door. Stairway. Here's my favorite. Stairway. You need a light for the stairway, as you can see. And only if you have, and you remember how many steps you need to have a 3-way switch? If you have 6 steps or more, this is kind of common. 6 steps or more, you're going to have a 3-way switch here and a 3-way switch here. 3-way switch here and a 3-way switch here. Are you guys with me? Only if you have 3-way switch, if you have 6 steps or more. Yes, sir. Code. Yeah. Good design. Put a 3-way switch. If you have 5 steps, I think it's a good idea to have. Personally, I think it's a good idea to have a 3-way switch, especially if it's my house. If it's your house and I'm wiring it to code, I wouldn't put one, because you bid it based on code. When you bid the job, you bid it based on code. I'm going to bring it to code. A 3-way switch means more expensive and more wires. Yes, sir.
So let's say, like in a family room, and you said you gotta have at least one light switch or whatever, can you put it like a split receptacle?
Yes. In habitable areas, you can switch a receptacle and make it that light. A switch receptacle with a switch, make it light. Except this is not approved in 2 locations, 3 locations. You can't use a receptacle. 4 locations. I keep 4. Location number 1 in the kitchen. You can't have your light in the kitchen as switched receptacle. Number 2, the bathroom. You can't have a switched receptacle in the bathroom as your light, switch receptacle. So number 1, stairway. You can't have on the stairway a switched receptacle. Makes sense, right? And mechanical rooms, like utility rooms and all that stuff, you can't have a switched receptacle on the floor as yours. You have to have a lighting fixture. Though you can argue that I put a receptacle there and plug a light and switch that receptacle. So, but they don't want to put one of these receptacles where you can switch them. Most of the switched receptacle light, they use them, guys, in common air in living rooms, family rooms, as well as bedrooms. I don't like them. Anybody likes them? I like my light in the ceiling. But yeah, you can use, you walk in and there's no light in the ceiling. How do they make the code in a bedroom? Well, guess what? They switched one of these receptacles. Any question guys about lights? Wall mounted switch for the following location. Wall mounted switch like this. You need a wall mounted switch for the stairway, a wall mounted switch for the garage, for the stairway. You need one for the kitchen and one for the bathroom. Otherwise, a lot of other locations, guys, you can move in and use the fixture to turn on and off a pull chain. Any question about lights? We'll talk more about lights as we go to, guys, in the common area for our project. Yes, sir.
Switch one for living room too as well.
Switch what?
Switch light for living room as well.
The living room mean a wall mounted switch. A wall mounted switch. It can't be a pull chain in the ceiling for the living room. Yeah, you can. I wouldn't do it, but you walk into the living room and you pull a chain to turn the light on and off. You can by code. It's not a kitchen. It's not a bathroom. Any habitable space need a lighting outlet. Your lighting outlet in the living room could be a switch receptacle or a lighting fixture. No, if you don't put anything in the ceiling, not against code, because as long as you account for a wall switch, the switch one receptacle for your light. The what?
If you don't have one in the ceiling, you don't have a switch outlet.
Oh, that's against code. You don't have an outlet. You don't have a lighting outlet. You have to have something to, is it? Yeah. Yes,
So
sir.
you just have plug-in lamps or something?
Our lower level of our apartments, we have to look at storage under the stairs. We want to put like a keyless.
Good idea. Very good idea. Either keyless or throw a switch for it. At least a keyless.
A keyless.
The one that pull
The full chain.
pull chain. I hate the term keyless because it indicated doesn't, it confuses it, indicate you don't have a key to it, right? When in reality you have that little pull chain. Okay, any question guys? I hope that will help you guys start your design. If you want to go down, I encourage you to go down and see what those guys are saying. And thank you.